Dear students, welcome to my channel Elite Maths class. Today I am here with the last part of determinants. Already 5 different parts. In these various parts I have discussed all the theoretical parts of determinants. In this last part I will discuss application of determinants. So if you are watching first time, you first go through the links given in the description box for my previous videos. Application of determinants. Here in our syllabus there are various application of determinants in the higher mathematics. Here in our class 12 syllabus, here we have to find area of a triangle by using determinants. This is one application, and the another application is solution of a system of linear equations by using determinants. That method name is Cramers Rule. So let first see how to find area of a triangle by using determinants. In the coordinate geometry, there is a formula for finding area of a triangle. Say this is a given triangle whose vertices, coordinates of vertices are say x1, y1, coordinates of these vertices say x2, y2, and cb x3, y3. Then from coordinate geometry, there is a formula for finding area of this triangle, area of triangle ABC. Just remember that this was the formula, half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 modulus of this square unit. This was the formula by using our coordinate geometry concept. Now how to find area of the same triangle by using determinants? For this, these are the vertices of the triangle. Now using determinant, area of triangle ABC equal to, this will be a determinant of order 3 by 3, half of this, see half is there, this half is also there. Now how to express this expression by using a determinant? You just have to write, see the first point, it is x1, y1, then you have to write the first row as x1, y1 and 1. Now the coordinates of the second point is, it is x2, y2, then we have to write the second row as x2, y2, 1, and the third point is x3, y3, then we have to write x3, y3 and 1 square unit. So after expanding this determinant, you will get the same value as this formula is giving us. So this is the formula. Here one thing you remember, that we have to take the absolute value of the determinant, absolute value of this determinant, as we know that the value of a determinant may be positive, may be negative, but area of a triangle cannot be negative. See, after expanding, if the value of the determinant is negative, then for the area of the triangle we have to take the numerical value only. Let us see this by an example. Say, let us take another triangle. Say this is the triangle, A is the point, say 2, 1, B is the point, say through 2, minus 2, 3, minus 2, C is 1, minus 1. Then what will be the area of the triangle by using determinant? Area of the triangle ABC, half determinant. So what will be the first row? x1, y1, 1. Here x1 is 2, y1 is 1, and the last one 3 minus 2, 3 minus 2, 1. Then the last point is 1 minus 1, 1. Now expand this, half will be there. 2 into minus 2 plus 1. The method for expanding a determinant already discussed in my previous video. So if you are new to this, if you are first time watching, you first go through the videos, links in the description box. Minus 1 into, it will be 3 minus 1 plus 1 into, it will be minus 3 plus 2. So this is equal to half into minus 2 plus 1 minus 2, here it is 2 into minus 1 minus 2, here it is minus 1 minus 3 plus 2 minus 1 into 1 minus 1, so in total it is minus 5. So the value is minus 5 by 2. As I have told earlier that if the value is negative, then we have to take the positive value only. Therefore area of triangle ABC is just take the positive value, that is 5 by 2 square unit. So this is one application of determinant. By using determinant, how we can find the area of a triangle. This also very helpful for entrance exam problems in the complex number or in the vector. You will get some problem involving determinants or triangles. That is, whenever you have to find the area of a triangle, you can use easily the determinant formula. This is also very easy to memorize. As the coordinate geometry formula, it is a lengthy expression. So in this short form, just simply memorize that. Just you put the values of the coordinates and the last column is 1 1 1. That's all. So hope the application of determinant, first one, how to find the area of a triangle, is clear. Now let us see the second one, that is the Cramers rule. It is also another application of determinants. Now let us see the second application of determinants, that is Cramers rule, which is called the Cramers rule. This is actually the system of solving a linear equation, that is the process of solving a system of linear equation by using determinants. That method was introduced by the great mathematician Cramer. That's why this rule name is Cramers rule. So before that, let us see what is a system of linear equation. See here, three equations are written. How many variables are there? There are three variables, x, y, z. So the system involving linear equations, whenever number of equations equal to number of variables. See here, number of equations 3, number of variables 3. This type of system package is called a system of linear equations. Again, whenever if you take two variables x and y, so if the variables are 2, that is x and y, then there will be two equations. That is a system. Here, by for an example, I am taking three variables with three equations. That is a system. So the system of linear equation is clear. And another thing, why it is called linear? See, the variables are x, y, z, and all are in linear power. That is, the power of the variables is 1. That is the system of linear equation. So number of variables equal to number of equations. Now see what is a Cramers rule, or by using determinants how we can find the solution of this system. There are actually three cases. The system may have a solution, may not have a solution, and if the solution exists, then it may be unique or it may be infinite. That part I will discuss in my next video. Now let us just see the process, how to find the solution of this system by using Cramers rule. First of all, we have to form a determinant. I give the name as del. Now how to form del? Del will be a 3 by 3 determinant, as we are taking three variables and three equations. So how to form del? Just take the coefficients of x, y, z. See here, in the first equation, coefficient of x is a1, coefficient of y is b1, coefficient is z is c1. So it will be the first row. Coefficient of x, y, z from first equation will be the first row. Similarly, coefficient of x, y, z from the second equation will be second row. Coefficient of x, y, z from the third equation will be the third row. So a determinant of order 3 is formed, and then what we have to do? Then we have to expand the determinant, and if the value is not equal to 0, this is the necessary condition. This is the necessary condition for application of Cramers rule. The value of this determinant must be not equal to 0. If this determinant equal to 0, then remember that Cramers rule is not applicable to this system. Clear? Next, what we have to do? Next, we have to form another determinant, give it the name del x. Now see how this determinant is formed. Del x equal to, exactly similar to this one. Now what to do with x? X here means we are forming this determinant for the value, to get the value of x. So what is, these are the coefficient of x of all the equations. In place of this column, we have to replace the constant in the right hand side, d1, d2, d3. So the first column will be d1, d2, d3. That is, whenever you are writing del x, the coefficient of x will be replaced by the constant terms of the given equation, then the second column will be unchanged, third column will be unchanged, then expand it whatever be the value is. So del x is clear. Similarly, next thing we have to do is we have to find del y. Now see how exactly in the similar way del y. Y means this column is for y, coefficient of y. So this column will be replaced by the constant term. So in this case, first column will be unchanged, second column will be the constant terms d1, d2, d3. Then the third column will be unchanged as in del c1, c2, c3. Then expand it whatever be the value is. Then we have to form another determinant of order 3. This is del z. Z means here we have to replace the column forming by the coefficient of z will be replaced by the constant term. So in this case, first and second column will be unchanged. Here we have to write a1, a2, a3, b1, b2, b3, and the third column will be, as in the previous cases, third column will be replaced by d1, d2, d3. Then expand this determinant whatever be the value is. So hope how to form del, then how to form del x. Just what is del? Del is the determinant formed by the coefficient of x, y, z. Then how to form del x? Del x, in del x, the constant term of the given equation d1, d2, d3 will be a column. In which place? It will be in place of the coefficient of x, that is in the first column. What is del y? Del y in the second column, you have to replace this second column by the constant terms. And in del z, what will be del z? In del z, you have to replace the third column by the constant terms of the given equation. So we are having 4 determinants. Del, the first thing, you just after writing del expand this. If del not equal to 0, then the Cramers rule will be applicable. If del equal to 0, then Cramers rule not applicable in this case. Then form del x and find the value of del x, then form del y, find the value of del y, then form del z, find the value of del z. If del z, del y or del x is 0, no problem, that is the values of del x, del y, del z may be 0 or may be non-zero. Then by Cramers rule, what will be the values of x, y, z? Then by Cramers rule, what will be x? X will be del x by del, y will be del y by del, z will be del z by del. So these will be the values of x, y, z. Very easily we can obtain just by finding 4 determinants. This process is called Cramers rule. So what is the benefit of Cramers rule? See, there are 3 equations, 3 variables. If you want to solve these equations by the previous methods which are already known in class 10, that is, you can eliminate x from equation first and second, then eliminate x from second and third, then these will reduce to 2 variables, then solve, then put the value of y and z in any of the given equation, you will get. This is a very lengthy process. So in this point of view, Cramers rule is very important and a very shortcut to solve a system of linear equations. Now see this numerical example, that is the application of determinant, that is the Cramers rule. Here see, 3 equations are given with 3 variables, that is this is a system. See one thing here, in the first equation 3 variables are there, in the second equation x, y, z is there, but in the last, that is the third equation, x is not there. So here we have to rewrite something, as x is missing, we have to write the term of x with the coefficient 0. And if here also, if the constant term are not in right hand side, you just rewrite them, write all the constant term of every equation in the right hand side. Then as in the process I have discussed, so first we have to find del. Del is what? Del is just by is the determinant by taking the coefficient of x, y, z. See 2 1 minus 1, sorry 1 1 minus 1, then 2 3 1 0 8 3 equal to the value of the determinant. You just find out the value of the determinant, it is 2 into 1. See one thing, it is not equal to 0, that is the necessary condition is satisfied, that is for this system we can apply Cramers rule. Now from del x, what is del x? In del x, to form del x in del, what we will have to do? We have to replace the column for x, that is column for the coefficient of x will be replaced by the constant term in the right hand side, that is minus 3 2 will be minus 3 2 1 will be here. See, minus 3 2 1 and the remaining two column are unchanged. In del y, second column will be replaced by the constant terms 3 minus 3 2 1, first column, third column unchanged. The value of the determinant is 21 and by expanding value of del x is minus 21. In del z, third column will be replaced by the constant term of the given equation minus 3 2 1 in the third column, and by expanding we see that value of the determinant is minus 63. So see, here we have all the values of del x, del y, del z. So by Cramer's rule, what will be the values of x, y, z? Now simply then you write by Cramer's rule. So what will be the value of x? The value of x is del x by del. Now what is the value of del? Del is minus 21. What is the value of del x? It is also minus 21. So the value is 1. Now what will be y? Y will be del y by del. What is the value of del y? Del y is 21. 21 by minus 21, it is minus 1. So what will be value of z? Z will be del z by del. Del z is minus 63 by minus 21, it is 3. So the answer is therefore x equal to 1, y equal to minus 1, z equal to 3 is the solution of the given system of equation answer. So hope this Cramer's rule is clear. These are the application of determinants according to your syllabus. In this chapter, two applications are there. One is finding area of a triangle by using determinants, and the second one is solution of a system of linear equation by using determinants. That is the name of the process is Cramer's rule. Hope these are clear. In my next video, I will discuss what is consistency and inconsistency of a system of linear equation, that is the test of consistency. That is also another part of Cramer's rule. So in my next video, wait for the next video. I hope this was very helpful. If this was very helpful, please don't forget to subscribe my channel. Thank you for watching.